Hi guys, in our previous video we have discussed the photochemical cycloaddition reactions of different organic molecules like cycloaddition reactions of alkene with alkene, cycloaddition reactions of alkene with enone, cycloaddition reactions of enone with allenes. Also we have discussed the diamine reactions. Now we will have discussed with photochemical reactions of carbonyl compound. Here mainly we will discuss the two different types of cleavage of carbonyl compound under photochemical conditions. One is called Norrish Type I, another is called the Norrish Type II. The Norrish Type I, when the carbonyl compound by the UV light get excited, this UV light radiation range is 295 nanometer to 400 nanometer. That time the alpha cleavage happen near to the carbonyl. So this cases this carbonyl compound, the lone pair of electron gets excited. So here n to pi star transitions happen. Now this gives this biradical species of this carbonyl. Further the break of homolytic cleavage of this substituent attached to the carbon that happen gives this acyl radical and the substituent radical. Further this undergo reactions. Now this alpha cleavage, which side alpha cleavage will happen depends on several factors. One is the radical stability, another is the molecular structure of that carbonyl compound. Let's have a look of one example. This is the methyl substituted cyclohexanone under photochemical condition. Here this side, due to the stability of the radical, cleavage happens, and there is the two possibility where the elimination of hydrogen produce these two different types of product. One from here gives the ketene and another from here gives the alkene. Now this is the another example where these molecules under photochemical condition gives this biradical species which further generates this benzene and carbon dioxide. Now coming to the mechanism 2, which where we will see the Norrish type 2 or type 2 fragmentation. Here this is the carbonyl compound that must possess a gamma hydrogen. So that cases if it absorbs the UV light, that cases this excitations gives this biradical species of the carbonyl. Further this oxygen radical abstract the proton from the gamma position, produce this another biradical intermediate. Now this have three different possibilities. One, it's again converted to starting material, either it gets cyclized, give to product, or it gets eliminated near this radical gives this eliminated product. One is enol and another is the olefin. So now which type of product will form, either it will cyclize or it will give the eliminated product, it depends on the stability of the radical intermediate. Also if near the beta position, if heteroatom is there at beta position, that cases cyclization will favors than the elimination. Now if there is no gamma hydrogen at the gamma position of this ketone, then if we have this photochemical condition, that cases there is also a possibility of delta hydrogen abstraction which can produce this cyclic product, but that is less efficient compared to the gamma hydrogen abstraction. One more interesting thing observed that when these gamma position are chiral, that cases started with these photochemical reactions. When direct irradiation happened, that cases it was so fast going through the singlet state, so that cases it's relaxed so quickly the stereochemistry is written. That was the stereospecific. But if its reactions happen through the sensitizer, it gives the triplet energy to this molecule, and which gives this biradical species, and this biradical species relaxed very slowly, so that cases this center gets racemized, give the racemization happen of the center, so stereochemistry not written. Now we'll discuss another interesting type of reactions called Barton reactions, where it is the reactions of alkyl nitrite or nitrite ester. Under photochemical condition, it can produce that γ-hydroxy oxime. How these reactions happen? The mechanism is this nitrite group has the homolytic cleavage under photochemical condition. It generates one nitrosyl radical, another oxygen radical. That oxygen radical abstract the delta hydrogen from this alkyl species, and at the delta position that radical generates. Here this nitrosyl radical and the delta position carbon radicals combine gives this product, which tautomerized gives the hydroxyl amine, means oxime product. Now this is very important for remote functionalization, because we can at the delta position we can get the functionalization under photochemical condition. If there are number of delta hydrogen now which is close proximal to this nitrite, that will undergo functionalization, means oxime formation only happen to that delta position. And this is the another reaction condition where that hydroxyl group with nitrosyl chloride gives this nitrite generates first. Further it's undergo reactions with photochemical condition, produce the oxime product. So thank you. We will discuss in the next video.